Okay, as I told you, I'm going to be out for a little bit, and probably all of the rest of this week and all of next week. So I thought rather than trying to cover new material, that we'd finish this second packet, kind of just get it all done. The immediate plan today is to do 16. Hold on. So we're gonna the first assignment should be 16 to 19. That's Wednesday, March 10th. And then next week, on the first block day, we're gonna do, the assignment will be 20 to 27 on the first block day. And then the assignment will be 28 to 32 on Wednesday, March 17th. And then the assignment for block 2 will be 32 to 40. And we should finish the second college placement test. That way you'll have 2 of them to have as study guides as we move forward. These will count as 4 assignments, 5 points each. Just like always, during the class period, you watch this video. It'll be a little bit different because it'll be on YouTube instead. At least that's my plan right now, to put it on YouTube. Then at the end of each period, submit it. I will attach this video, of course, to the assignment and to the announcement for the week. So you should have access to it. In theory, you could do these on your own, but do me a favor and just do them during the class time that we have set aside, because that's what I have set aside for the substitute. I'm not sure exactly who the substitutes are going to be. I think it's going to depend on the period. But obviously, please be respectful to them. Do whatever that they ask you to do. But the assignment for each day will be up here. Wednesday. The one we're going to do today. Is 16 to 19, and then we'll continue through. So you should have 4 assignments while I'm out. In theory, I should be back on that following Monday. And then we'll go back to what we were working on. If you're in the advanced topics, we're going to go back to the trigonometry on a circle, converting radians to degrees, figuring out what quadrant you're in, figuring out how to put everything back in standard angles, and all that. If you're in CP Calc, we'll go back to, well, actually, no, I think we finished the trig derivatives, so we'll start the chain rule, which is the big dog. That's that's once we know the chain rule, in theory, we can take the derivative of anything. It's kind of the last big hurrah, last big rule that we need. So, anyways, again, before we start, let's put ourselves in the presence of God. In the name of the Father, Son, Holy Spirit, amen. In the name of the Father, Son, Holy Spirit, amen. Okay, so let me slide down a little bit here. We don't need a schedule, but maybe leave it there. Just kind of out of practice. Try to leave the one question. I want to do the other one. Number 16. A circle shown to the right has a radius of 3 and a center at O. Now, as I told you before, I can't draw triangles or circles as good as Mr. Brown. But let me just draw a circle here and pretend it's perfect. We know that this is O. And so anyways, that's B here, and that's A over here. And again, it's not a perfect circle, but just go with it, okay? So I got and this is A here. So then this is 150. It's 150 degrees. And what is the area of the shaded sector? What's the area, right, of that? So basically, we're looking for the area for part of a circle. So we're going to have to remember our geometry, and we're going to have to remember a little, well, probably we could do this all from just geometry. But this kind of goes with, the trigonometry that we just kind of finished with both sections. Not like the trig functions, but just the idea of trigonometry on a circle. So we got this area here. And now, if it was the whole circle, we could do that, right? We know the radius is 3, right? Is it, or did it say 3? Yeah, the radius is 3, right? I was just checking for units. They're not giving us any units. So it could be 3 miles, it could be 3 centimeters, it could be 3 millimeters, it could be 3 inches. We don't know. It just says the radius is 3. So if it were the whole circle, we know the area of the whole circle is pi r squared. Now, if you're in calculus, notice what the derivative is, right? Notice what the derivative is. This is a digression. I'll do the digression in green here. That's pretty cool, isn't it? Right? The derivative of area is perimeter. It's weird, right? It's kind of cool. It works for other things, like the volume of a. If you write down the volume, if you write down the volume of a sphere, which is what, 4/3 pi r cubed. If you take the derivative of volume of it, notice you get surface area. And that's consistent in general. There's obviously rules to it. It works perfectly for circles and spheres for reasons that I'm not going to get into here. But it's kind of interesting that the derivative of volume gives you the area formula, and the derivative of the area gives you the perimeter. So anyway, let me erase that, because that really isn't, just kind of a side note to all this. But anyways, so if it was the area of the whole thing, what would it be? The area of the whole thing would be 9 pi, right? The area of the whole thing would be 9 pi. But we don't want the whole thing. We just want that part. Now what we have to remember is we want 150 degrees of 360, right? So if we didn't have a calculator, what we'd have to say is, I don't want the whole circle. I want a fraction of that circle. I don't want this whole 9 pi. I don't want the whole 9 pi. That's not the answer. I have to modify that because I only want this part. I only want that part, right? So if I only want that part, that's 150 degrees out of 360. So I want 150 degrees out of the 360. Now you have to remember that there are 360 degrees in a circle, but I think all of us pretty much probably know that, right? So now, how do you simplify that? Like how do you make that match one of the 4 answers? Well, we all know how to simplify, but everyone does it differently, right? So it's up to you. Up to you how you want to simplify this. Probably the easiest way to do it is to grab a calculator and do it. But the truth is, usually these tests tell you can't use a calculator on them, right? So let's just, we all know how to do it, but you divide by 10, so I get 15 times 9 over 36. 9 goes into there 4 times. I think there it is. Now, I got 15 pi over 4. Now, obviously you can simplify that however the heck you feel like simplifying it. It doesn't matter, but that's the right answer, right? So what is that? A is an apple. So the first answer, number 16, is A as an apple. again, you got to remember your area formula, and you got to remember there are 360 degrees, and you have to remember that what we want is a fraction of that circle. We want 150 degrees of the 360 degrees. So I want a fraction of the area there. Okay. Okay. So move on over. Back up just a little bit. It's kind of weird, but the YouTube sizing is a little bit different than the classroom. You probably see this line. The YouTube's a little bit wider, it looks like to me. I don't know. I'm just looking at the videotape right now, but yeah, that black line is a line I keep there when I'm on Zoom, because I know that you guys can't see above that line, right? So I have to make sure I just don't write too high. I set it up so it goes to, as a matter of fact, now you probably see the sill, but you probably don't see on Zoom, right? Just weird stuff that I'm thinking about. Okay, so the next one. This one drives students batty because of the roots, right? But the basic rule goes back to something you learned probably in 8th grade in Algebra 1, or 9th grade in Algebra 1, right? If the question, I guess what I'm saying is, if the question used different numbers, it would be like super easy. But the fact that they're not is really the point. But they're still testing the same exact idea, right? So what they have here is what they say the third root of t over the fifth root of t. Now let me digress. Okay, let's not answer that question. I don't know if I was being clear about what I was saying. If it were t, well, let's use different variable. Let's just use x. If it was x to the third divided by x to the fifth, we would all know that it's x to the 3 minus 5. Well, I'm assuming we'd all know, which would be x to the negative 2. Why? Because x times x times x over x times x times x times x times x, right? So, you know, we don't do this, right? So you get x squared, and when that's in the bottom, that means it's actually negative 2, right? This is, again, a digression. This is not the question, unfortunately. But what am I getting at? The rule's the same, right? The rule's the same, right? You're going to take 3 minus 5. So when I rewrite this here, when I write this as 1/3 over t to the 1/5. Now, here's the thing. 1/3 minus 1/5 is much more challenging to do than 3 minus 5. I'm not saying it's super duper hard, but you know, we just have to realize that the rule is the same, though, right? The rule is the same. I'm going to take t 1/3 minus 1/5. The problem is when I bring that up, we can't probably do that in our head. Well, some of us might be able to do it in our head, but let's work it out. Remember how we do fractions? 1/3 minus 1/5. You got to get what's called a common denominator. And so what you're going to do here is multiply top and bottom by 5, and here top and bottom by 3. And so when you do that, what do you get? 5/15 minus 3/15, which is 2/15. So you end up with t to the 2/15, it looks like. And then of course what you do is you look and see if it matches one of your answers, and you hope to God that it does, and in this case it does. It looks like B as boy. Okay. I could probably try to do 18 without sliding over, but I guess you hit pause right now if you're not ready to move on. Hit pause if you're not ready. If you haven't, you're not done with 16. I'll probably leave 17 in there. So, beep, 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 beep. Okay. 18. Adding fractions, right? 3 over x minus 3 plus x over x plus 3. Again, remember the philosophical thing going on here? Same thing we just did over here. Okay. Matter of fact, maybe I can use that as a guide here. How did I get the 15? I I realized that I had a 3 here, but I need a 5, and here I had a 5 and I need a 3. The same exact logic. Let's do that. Let's do it in green, just like I did there. So again, this actually it was the work for B. Sorry, not for B, for 17. Watch how this works here. What I'm going to do here is I'm going to multiply x minus 3, and over here x plus 3. In the same way that I multiplied the 5. This, like this was the 5 and that was the 3. But remember, you can't just do that, right? You have to multiply by 1, right? Because 1 is the identity element for multiplication and division, right? Since it's the identity element, as long as we multiply by 1, we're not going to change the question, right? So I'm going to go x minus 3 and x plus 3. So notice what I'm doing. 5 over 5 is 1. 3 over 3 is 1. X plus 3 over x plus 3 is 1. So it's the same exact idea, but we're doing it with an algebraic thing. And this is back from Algebra 1, of course, too. So let's see what happens when I do that. Remember to distribute. The most common wrong thing here to do is to forget to distribute the 3 into both. It's 3 times x and it's 3 times 3, so make sure you get the 9. And then over the common denominator, oh crap, that's a minus. Hold on, otherwise we wouldn't have a common denominator, would we? Plus, and then again distribute here, x squared minus 3x over x plus 3. Now, what's going to happen here is we have to make sure it looks like the answer that we want. So let's see what happens here. 3. Okay, notice that. Let me actually switch to red. Notice the 3x are going to cancel, and I'm going to get 9 plus x squared over x plus 3, x minus 3. Now you'll notice that doesn't actually match any of the answers exactly, but it does, right? We have to do a little bit of manipulation here. A plus B is the same as B plus A. 9 plus x squared is the same as x plus 9 squared. So just to make it look right, x squared plus 9. And then on the bottom one, first times first. And then outside is negative 3, inside is positive 3. So outside and inside is going to cancel. And then last times last, a positive times a negative is a negative. And that does match. And that would be C as in cat. And that would be C as in cat. Okay. I said we're going to go to 19 today, right? What I tried to do is divide up the remaining questions that we had into 4 groups. Now, in advanced topics, I know there are 10 questions we still haven't done. What I did was, in advanced topics, we only got through 5 because there was a couple weeks that on Wednesdays we didn't do it, whereas in the CP Calc we did 3 Wednesdays, so we were at 15. So don't with advanced topics we will go back and do those 10, but just to be honest, I didn't want to have to make 2 videos on the same stuff, so I thought I would do these 4 videos on the material that both classes were missing in common. Okay. And then we'll be done with this packet essentially. Except advanced topics, we'll still have 2 more Wednesdays to finish up on those. Okay, last one, trying to leave that one in, number 18. Last one for today, Wednesday the 10th, number 19. This is a geometry question. It's kind of convoluted, kind of cool. You got a square, A, B, C, D. A, B, C, D. And then you got a parallel line here and a parallel line here. So these lines are said to be the area of the square shown to the right is the area of parallelogram that is 24. So what we know is that this area here is 24. Kind of a cool question. Kind because you have to think about it a little bit, especially if you haven't done parallelograms and you might not remember formulas and stuff, but you could probably still figure it out even if you don't. So we know that that area is 24. So that area is 24. The question is, what is the perimeter? Well, what's the perimeter of the square, right? What I'm going to want is just one side, though. If I can figure out one side, then I could figure out the perimeter because I just have to multiply by 4, right? Because it's a square, so once I figure out one, I'm golden, right? So you have to remember, oh, and I think they did tell you one other thing, I apologize. They say that CF is 3. They say CF is 3. Now, you might not remember this, but this is what you need to know. And this is what they're testing, right? What is the area of a parallelogram? What's the area of a parallelogram? The area of a parallelogram area is base times height. Now you might go, well, I thought the area of a triangle is 1/2 base times height. Yeah, because because the parallelogram is two triangles, right? If you think about it, these two triangles are the same, right? So basically, the area of a parallelogram, that's how I remembered it when I was a kid. The area of a parallelogram is twice the area of a triangle, which is 1/2 base times height. So the parallelogram formula is pretty easy, right? The parallelogram formula is just base times height. Now you remember that, but the correlation I think is nice to know, and you can tell because it basically makes two triangles. Now the way I drew it, it looks like it's perpendicular, but it doesn't matter. Like if you just connected them, you'd recognize that both those triangles are exactly. The picture in the book on here wouldn't yield a perpendicular there, but if you just connected this one to this one of any parallelogram, it makes two triangles, right? And they still have the same base and height, so that means they got to connect it. I'm probably over-explaining this and going back to my own childhood, trying to connect things together, right? But anyway, so the area of a parallelogram, let's just not worry about triangles then. This area here is 24. The area of this parallelogram is 24. We know that. We know the base of the parallelogram is 3. So we can find, now remember the height is right here. And that's the important thing, right? The height of this thing there. And that's what I need, right? Because if I can figure out that side, I can just multiply by 4 to get the perimeter, right? So I know that's h. But that's not a hard equation to solve, right? Just divide both sides by 3. So I can calculate that's 8. And so again, we're almost done here, right? So that's going to make this the area. No. The perimeter is going to be 4 of those 8s. So the perimeter is going to be 32. And that's the answer to the last one for today. So what's that? C as in cat. Okay, just a couple things before we quit. We're going to continue with this for 2 reasons. One is I want to make sure you have a second college placement test to be able to go over when you are getting ready to do your placement test, so you have something to review and study. And the other is I don't want to cover new material. It sounds kind of weird because we're doing it remotely anyways, but I'd rather do new material live, like when I'm actually there, just in case people have questions and stuff like that or whatever. So anyways, so we're going to continue this process for the next, all next week. So block day Wednesday and block day next week, we're going to break up the remaining, 20 questions. I think we're on we're 21 questions left. So we'll finish that up. And like I said, with the CP class, we will, the 8 advanced topics class, we will go back later and do the 10 that we're skipping. We started at 16 and we were only on 5, but that's because that's where the other class was, and I wanted to just have to make one video for each of these 4 days that I was going to be missing because of my surgery. Okay, I will see you guys in a couple weeks, but I'll be back on video Monday or Tuesday, depending on what day you have me. Okay, bye-bye.